The evolution of technology is a fascinating story that has changed the way we live, work, and communicate. But did you know that it all started thousands of years ago with a simple counting tools like the abacus? Today we will explore the incredible journey of computing from the first mechanical devices to the modern processors that power our smartphones. Hello, how are you? My name is Liz Mendez. I belong to the National Polytechnic Institute of Mexico, Chetumal campus, studying civil engineering. And today I will talk about the history of computing and how it has evolved. We begin in Mesopotamia around 2000 BC, where we find one of the first mechanical calculating devices, the abacus. This device was used for basic calculations related to accounting and resource management. Although there is no direct evidence of a similar Egyptian abacus, the ancient Egyptians used marked boards to keep counting records around 1300 BC. In Greece, around 500 BC, the Salamis abacus was developed, a more advanced tool with groups on a marble board for placing stones or tokens. The Romans adopted the Greek abacus, using a portable version with metal beads suitable for the Roman numeral system. In China, around 1200 AD, the Swamphan revolutionized calculation. This abacus had two levels of beads, allowing for more complex operations, such as multiplication and division. Moving to the 1st century BC, the astrolabe was used to solve problems related to the positions of stars and planets. Although not a calculating device in the modern sense, it propelled mathematical thinking. The Antikythera mechanism, discovered in a shipwreck in 1901 and dated around 100 BC, was an innovative machine for predicting astronomical positions and eclipses. In the 17th century, Islamic mathematician Al-Khwarizmi made great advances in algebra. His work systemized the solving of linear and quadratic equations, giving rise to the term algebra. In 1202, Leonardo of Pisa, better known as Fibonacci, published his work, Liber Abaci, where he introduced the Hindu-Arabic numbering system in Europe, replacing the Roman system. This book also presented the famous Fibonacci sequence, a mathematical succession, with applications in numerous fields. The introduction of decimal system by Fibonacci facilitated complex calculations and promoted advances in both mathematics and science. Advancing to the 17th century, Jean Napier developed logarithms in 1614, simplifying multiplications and divisions. This greatly facilitated complex arithmetic calculations. In 1662, William Othred invented the slide rule, a tool for performing multiplications, divisions, square roots, and logarithms. Blaise Pascal, in 1642, created the Pascaline, one of the first mechanical calculators capable of performing addition and subtraction. Gottfried Wilhelm Leibniz, in 1672, improved upon Pascal's ideas with the step reckoner, a mechanical calculator that could perform addition, subtraction, multiplication, and division. He also introduced the binary number system, fundamental to modern computing. In the 19th century, Charles Babbage designed the difference engine and the analytical engine, precursors to modern computers. Although they were not fully constructed during his lifetime, his concepts were crucial for the development of computing. Lady Ida Lovelace, in 1843, expanded upon Babbage's ideas and suggested the use of punch cards for performing repetitive operations on the analytical engine. William Stanley Jevons, in 1869, invented the logical piano, a machine that used Boolean algebra to solve problems more quickly than humans. Ramon Verrea, in 1878, developed a calculator with an internal multiplication table, revolutionizing speed in calculations. In 1879, Hermann Hollerith created a computing system using punch cards for the U.S. Census an innovation that had a significant impact on data processing. Otto Steger, in 1893, developed an automatic multiplication machine that found applications in both business and science. The 20th century brought significant advancements in computing. The first generation of computers, like the Colossus in 1943 to 1944, was one of the first programmable electronic digital computers. In 1945, the ENIAC became the first generation purpose electronic computer, while the UNIVAC I launched in 1951 was the first commercial computer. The second generation of computers in the 1950s and 1960s saw the use of transistors, replacing vacuum tubes. Programming languages like Fortran and COBOL were also developed during this time. The third generation saw the introduction of integrated circuits and mini computers like the PDP-8 from Digital Equipment Corporation. In the fourth generation, microprocessors like the Intel 4004 from 1971 revolutionized computer design. The Altair 8800 and Apple II popularized personal computers. The fifth generation brought advancements in networks and software like the creation of ARPANET and the development of graphical operating systems such as Windows and Mac OS. The 21st century has witnessed revolutionary advances in the world of computing and technology. In May 2000, Intel launched the Itanium processor designed specifically for high-performance servers and workstations. This Intel was first 64-bit processor, enabling superior performance and greater memory capacity compared to 32-bit processors. In March 2001, Apple launched the Mac OS X, its first Unix-based operating system. This system was designed to replace the Mac OS 9 and offered a more stable and secure platform with a new user interface and improved integration with other Apple devices. The AMD Opteron processor, launched in April 2003, was the first 64-bit processor designed for personal computers. Its compatibility with both 32-bit and 64-bit operating systems allowed for superior performance and greater memory capacity, laying the groundwork for a new era in home computing. In October 2004, Ubuntu was launched. A Linux-based operating system was designed to be user-friendly, secure, and stable. As open-source software, Ubuntu is maintained by a community of developers and remains popular among Linux users. In June 2007, Apple revolutionized the mobile phone industry with the launch of the iPhone, the first phone with a touchscreen and an intuitive user interface. The iPhone also introduced the App Store, allowing users to download third-party applications, forever changing the way we interact with mobile technology. In November 2008, Intel launched the Core i7 processor, the first quad-core processor for personal computers. This advancement significantly improved performance and the ability of computers to efficiently handle multiple tasks. Microsoft launched Windows 7 in October 2010 as the successor to Windows Vista, with a more optimized user interface and better integration with mobile devices. Windows 7 quickly became one of the most popular operating systems. Windows 8, released in October 2012, introduced a new interface with dynamic tiles and was designed to be more intuitive and user-friendly for touchscreen devices, marking a shift toward more mobile devices. Windows 10, released in July 2019, was designed as a more secure and stable platform with a continuous updates and greater compatibility with virtual and augmented reality devices. Additionally, it improved integration with mobile devices offering a smoother user experience. The GPT-4 model from OpenAI, released in 2024, represents a milestone in artificial intelligence. GPT-4 is an autoregressive language model based on a transformer neural network architecture trained in a vast dataset of text. It is capable of generating high coherent and relevant text in various styles and formats, significantly improving language understanding compared to its predecessor GPT-3. In conclusion, from the abacus to smartphones and advanced artificial intelligence, the evolution of calculating tools has transformed the way we live and work. Thank you for joining us on the fascinating journey through the history of computing. Don't forget to subscribe to the channel, like and share your comments. See you next time.